Well, good evening, everyone. Today, Sean asked a question about period in terms of transforming trigonometric functions, and we kind of ran out of time, so I wanted to address that a little bit. Normally, you see a trigonometric function such as f of theta equals sine theta, which is all well and good, but there's a lot of hidden information that you don't see because of the multiplicative identity 1. For instance, f of theta really equals 1 times the sine of 1 theta plus 0. And it's kind of a shame that they don't include all this information because this first one is an indication of the amplitude. This one here is related to the period. It's not the period itself. I'll explain that in a moment. And this 0 is an indication of the vertical shift. So yeah, it'd be nice if we really included that all the time, just as a reminder of what all those mean. The general form you'll see in your book probably is f of theta equals a times sine or cosine b theta plus c. And that's good too, if you can leave some general terms there. And I should point out that for this to work, you have to have an understanding of B. And I think that's what was causing Sean some heartburn today. The period, as you saw in your book, is defined as 2 pi, which is a normal period, divided by B. So in our example up here, B is just 1, so it would not show. And for this, sine theta, the period, of course, is 2 pi. That occurs when B equals 1. And I should point out that this works for sine and cosine only, because the period of tangent, of course, is 1 pi, not 2 pi. So if you're dealing with tangent, this would be pi over b. So let's look at a specific example. What about if we had something like, let me think of something. F of theta equals 2 sine 3 theta plus 4. Something like that. Yeah, that should work. So if we wanted something like this, we would say, okay, oh, I don't like this. Gotta pause. I decided the one I gave you before was too much like my second example, so I'm going to change it. I apologize. Let's go for 3 sine 2 theta plus 5. So to begin with, we really need to find the period. So as we said earlier, the period equals 2 pi over b, which in this case is 2, equals pi. So we know that we'll complete this cycle at pi, which isn't shown down here, but we can add it. We have 5 pi over 6. There's 4 pi over 6, so each of these is a pi over 6. 4 down there. So right there is 6 pi over 6, or just good old-fashioned pi. Okay, so we're good there. And then we notice this plus 5 here. That's vertical shift. So we're going to go up 5 units from our 0, which is where we started with a normal sine theta. Up 5. And 3 is my new amplitude. So from here, from my axis of 5, I'm going to go up 3 units. So I think we're ready to graph this. We know our period is pi. So that is right there, pi. We're going to start at 0. It's sine function. So at pi over 2 will be in the middle. It doesn't look halfway. My scale must be wacky or something. Because there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Oh, I see it. I gotta go one more. That's not a problem. It's a good thing I caught that. That would have been embarrassing. Okay. Up there. That looks better. That looks better. So, I will start down here at 0. It'll hit 5. And then it will go up, come down at pi over 2. Right there. That's the middle. It'll min out. Notice my amplitude is 3, so I've got to go up 3 from here in the middle of these two. So there. And then between pi over 2 and pi, right in the middle there, I've got to hit the minimum, which is 2, because my amplitude is 3. It's going to be about there. And this is definitely not perfect. Not a great scale, but for these purposes, it should do. So you'll notice that right here, I go from 5 to 8, so my amplitude is 3, or from 5 to 2. There's my amplitude. I came up 5 units from 0 up to there, a plus 5, and I completed the cycle, or the period, in pi units. So there it is. F of theta equals 3 times the sine of 2 theta plus 5. Okay, so 7 minutes in, we have a little time. Let's do it the other way around. What if I gave you this graph and said, write an equation to model this? Probably a little bit tougher. You were feeling confident after that last one. This one's a little bit tougher, but we can still do it. When we write an equation to model this, it's going to look something like f of theta equals, first thing we have to do is choose sine or cosine. So looking at this, I feel like, and you can do either, but I feel like this was a cosine at one time and it just got shifted down a bunch. So I feel like let's stick with cosine. But as I said, you can go either way. So it would be some amplitude value A times the cosine of b theta plus c. Okay, we're on our way. We've done our first little bit. So now I'm saying to myself, okay, got to figure out the period. Where does it complete its cycle? So I go down here, look down here, and right about there it completes its cycle. And that is between pi and 2 pi, and there are 2 partitions, so that's a third, 2/3, 3/3. So it's in thirds. So this is pi plus 1/3 pi, which would be right there, then 4 pi over 3. 2 pi over 3 plus 1 pi over 3, 4 pi over 3. Okay, so that completes the period. So now I can say, okay, the period equals, what did we say, 2 pi over the b value. And we know what the period is. It's 4 pi over 3 equals 2 pi over b. Ooh, that's nice. Notice that I can just multiply numerator and denominator by 2, because 2 pi times 2 will give me 4 pi. So that means that 2b equals 3 here. Wish I had just a smidge more room. I can make a smidge more room down here. Let me just drag this down. Drag it all down. We need a little more space. Okay. So now I can say, okay, 3 equals 2b, so b equals 3 halves. All right, we're on our way. Life's good. We're cruising. B equals 3 halves. That can go back up here. My first one, so I can say f of theta equals something times cosine of 3 halves theta. Nice, nice. So then I can look at my amplitude. And the easy way to look at amplitude is to say, okay, what's my highest high? Is -1. So I can go A equals max minus min divided by 2. In this case, A equals, my max is -1. My min is down here, -7. So I have a -1 max and -7 min. Watch your signs. -1 minus -7 divided by 2. That equals 6 over 2, and that equals 3 is my amplitude. So it's going to be 3 cosine 3 pi, or 3 halves theta. And so if my amplitude is 3, that means 1, 2, 3, that I can bring in an axis right here. Remember, my original axis is 0. My new axis should be right in the middle. And I'm going to check that just to be safe. And I go kind of, okay, 1, 2, 3. That's pretty good. And 3 there as well. 3 there. So there's my amplitude. And then from that axis, I went 1, 2, 3, 4 down. So then it's -4. Outstanding. So now I have f of theta equals 3 cosine 3 halves theta -4. So now I want you, as always, to say, does my answer make sense? In this case, you can certainly use your calculator in radian mode and graph this as y sub 1 or y sub whatever in your equation editor, 3 cosine 3 halves theta, and definitely use parentheses there. So this is all one angle in radians, -4. And see if it doesn't look something like this. Note you will have to change your window down in this quadrant. You'll have to change your window so you're looking just at this. Okay, that's about all I have for right now. I hope this is helpful, and I'll see you all in class tomorrow. Bye.